Hi everyone, welcome back. By now you already know how to work with some basic data types such as integer, float, booleans, and string. In this video, you will learn about compound data types such as tuples and lists. These compound data types may have or may contain other data types or other types in their structure. We also call compound data types built-in data structures in Python. You will also hear about new concepts such as aliasing, mutability, and cloning. So let's start with tuples. Tuple is an ordered sequence of elements, and each element may have different types. Tuple is immutable. We cannot change the value of an element in a tuple. It's very similar. It's like strings, if you can remember. A string is immutable. Therefore, we cannot change a character or change the value of a character in a string. Tuple is represented with parentheses. Therefore, let's take a look at these examples. The first line here is this one is an empty tuple. Therefore, we bind this empty tuple to this name t underscore empt. We can assign a tuple value to a variable, let's say in this example t, by following this format. This means that t binds to this tuple value. It contains three elements, and the first one is an integer, the second element is a string, and the third is a float. We can access each element in the tuple using indexing, just like with a string. So here, the element, this will evaluate to 2 because the element or the value on index 0 is 2. And here, we can concatenate tuples like this one using the plus operator. And here we concatenate the first one with this second tuple, and this evaluates to this tuple which has 5 elements. This new tuple is a new object in the memory. And we can also slice tuple. If we want to get a subset of the tuple, let's say here in this example, we start with index 0, rather index 1, and up to 2 minus 1. So that's just one element, and then here it's this one. Take note the comma here. This comma signifies that this extra comma signifies that this is a singleton tuple or a tuple with one element. And then in this next example, 1:3, this gives us 2 elements of the tuple. So it's the element on index 1 and index 2. So this one gives us this tuple. And then we can also get the number of elements in the tuple by using the len function in this manner. And then here, if we assign, let's say we assign a new value to an element in the tuple, that will give us an error because, as I said, tuple is immutable like string. We cannot, or we are not allowed to modify an element, the value of an element in the tuple. If you'll notice, all this these commands or operations are very similar with the way we handled strings. So yes, they are very similar. The operations, the syntax are quite the same. So except that strings only has characters as its elements in the string, or it's in value in the collection or in the sequence of elements, while tuple may have different types of objects in it's in a sequence. So tuples, one of the important uses or purposes of tuples is that we can conveniently use tuple to swap variable values like this one. So if you're going to use tuple, we can swap the values of x and y in this manner, with just this one line, compared to these three lines wherein we would have to use an extra or a temporary variable. Tuple also may be used to return more than one value from a function. We learned previously that the function returns only one object. And if we want to return more than one value, we can use tuple, because tuple can return, it's just one object, but it can have many elements within this object. So the elements or the values we want to return, we may put it in a tuple object and then return that object to the function that called it. Here, let's take a look at this example. We have there a function quotient and remainder, and this function returns the quotient and the remainder of x when x is divided by y. And you will see this operator slash slash or to division. This is the integer division, and this just means that it gives the answer to x divided by y, truncates the decimal part. So this one gives the quotient, and then x modulo y gives us the remainder. Similar with string, we can also iterate over tuples. Actually, in the same manner as we did with string. So here in this example, let's say we have nums bound to this tuple. We have unique a variable or a name unique that initially is an empty tuple, and we go through each element of the tuple using this for loop. So for n in nums, so n will go through every element in the tuple nums, and then this program checks if n is in the tuple unique. If not, this will concatenate the singleton n with unique, and then this replaces the object that is bound to unique. And then you will notice here there is min and max. Min gets the minimum value in the tuple nums, and max gives us the maximum value in the tuple nums. Therefore, this program prints out the minimum, the maximum, and the unique values in the tuple nums. Then we go to another built-in data structure in Python, which is list. It's also an ordered sequence of information, just like tuple, and then denoted by square brackets, like this square brackets. We to access the elements in the list, we also use indexing, and a list may contain elements that are of the same type. Um, However, it can also contain mixed types. But then it's not common to use or to store mixed types in a list. So we usually use lists to store homogeneous or elements of the same type. List elements can be changed. It is mutable. That's the difference between list and tuple. And list, just like tuple, can also store or have as its elements different types of objects, including list. So a list can hold another list. So this is how we access the elements in a list. Here are some examples. So the first line, this one is an empty list, which we assign to the empty list name. And L is assigned this list. So the first element in the list is an integer 5. The second element is string P. Third element is an integer 8. And the fourth element is a list that contains 7 and 9. If we want to get the number of elements in the list, we again use the len function, and this will give us the number of elements in the list. And in this example, this evaluates to 4. The L index 0, which is the first element in this list L, gives us 5. And then L index 2, which is 0, 1, 2, which is 8, plus 1 evaluates to 9. L index 3, the last element in the list, evaluates to the list 7 that contains 7 and 9, which is a type list. L index 4, which is out of the bound of list already, this gives an error. And L let's say we have I, which has a value 2. L of index I minus 1 evaluates to P, since it is L index 1. So you'll notice here, it's also similar with how we access the elements in tuple and in string as well. So since list is mutable, we can change the elements in a list. And we can do this using the assignment operator. So let's say we have L here, which binds to this list object that contains this elements 1, 4, 3. If we assign 5 to indexed 1, our list now becomes like this one. So the list becomes this one, and take note that it is the same object that L is bound to. So here in this example, L binds to this same list. When we assign 5 to the second element or to indexed 1, the 5 just changes this element in the list, but it is the same list object. So iterating over a list is very similar with how we iterate over string and over tuples. We do it using this for loop. We go through each element I in the list from the index 0 until the last element of the list L. So since list is mutable, there are some operations or methods we can do, such as add and remove elements in the list. So here we can add an element to the end of a list, L, using the dot append method. So here is an example. Let's say we have the list 143. If we do L dot append 4, L now becomes this, L now binds to this uh, same list object that has an additional element with value 4. So this dot is actually, we call this methods or functions. Since I mentioned earlier that in Python, everything is an object. So this list is also an object. It has data, and objects may have methods and functions. For now, we can think of this dot do something as things that we can do, or we can do, or we can call with this object. In this example, it's dot append, so we can append to this object L, which we named L. The plus operator also works with list. So this is the concatenation operation also. It combines lists together and gives a new list. Let's say we have this example, L1 and L2. The concatenation or the plus operator here concatenates or combines, puts together this two lists. So this becomes 1, 4, 3 and 4, 4. And this becomes a new list object. Here, this new list object is assigned to the variable name L3. Take note that L1 and L2 remains the same. They are unchanged if we use the concatenation operation. And then there is also a method .extend, which appends. It's like concatenation, but then this one mutates the list object L. So here in this example, let's say we put this, or we run this L1.extend, and we have a list object inside parentheses 7 and 8 that contains 7 and 8. L1 mutates to 1, 4, 3, 7, 8. Therefore, L1 binds now to the same object, but that list object has additional 2 elements at the end. So that's how extend works. So it's a mutation of the same list object. We have to remember that there are operations that mutates and operations that creates a new object. So if there are ways to add elements into a list, there are also ways to remove elements in a list. So to remove a specific an element at a specific index, we can use del, like this with this syntax. And to remove an element at the end of the list, we can use .pop, and this one returns the removed element. We can also remove a specific element using .remove, and inside the parenthesis the element or the value that we want to remove. So this method looks for the element and it removes it, if the element has multiple occurrences in the list, it removes the first occurrence of that element in the list. If the element is not in the list, it gives an error. So let's take a look at these examples. So let's say we have a list that binds to this list. We have a list variable that binds to this list object. This contains 2, 1, 3, 6, 3, 7, 0. And there is a note or a comment here that we have to do this expressions in order. I mean this expressions in order because of the possibility of executing or running a mutation. So we have to remember that if an operation or a method mutates the object changes its value. So the next line here is L dot remove 2. So this removes the first occurrence of 2 in the list. And this mutates L, and L now becomes this one. So the elements of here is this one. So from the original 7 elements, now we have 6 elements. Then we put here L dot remove 3, and this evaluates to this one. This mutates L to L rather with that after we remove the first occurrence of 3 in this L1. So now we have this new value of L. Del, then we delete an element, let's say here, del L index 1. This removes the element on index 1, which is 6. So here, this mutates L, and L becomes this one. This is the new value of L. We can do pop. So this one dot pop returns 0 because that's the last element here in the list. And this mutates L to this one. L's value now is this. It has 3 elements, 1, 3, 7. This is the final state of L after executing these methods. So in Python, we can convert lists to string and strings to list. As we know, strings are immutable and list is mutable. So this helps programmers to manipulate or to change the values in a string. Because if we convert a string to list, the elements or the characters stored as a list may be changed by using a simple assignment operation. So to convert string to list, we can use this list S, and this returns a list with every character from S and as an element in the list L. And then we can use S dot split to split a string on a particular character. If there is no character inside the parenthesis, this splits using the space character. And to convert, to turn a list of characters into string, we can use this dot join L. So let's take a look at these examples. Let's say we have a name S, and that name S is bound to the string DCS space dash space UP. So S is a string, and list of S returns this list with the characters in this string as elements of elements in the list. S dot split, and then we have here the character dash splits the string into, since there is only one hyphen here, one dash, so this splits into two elements, which are both strings. And here, let's say we have a list L, and L is bound to, or is assigned the list A, B, C. So here L is a list, and if we do dot join, this returns a string. And if there is a string here, or characters before the dot, that becomes the values in between the characters in the string L, or in the list L. So this is like a delimiter. There are a lot other operations for list. You can take a look at those in the Python documents. Anything you want to learn about Python, if you want to know more about it, you can go to the docs, Python docs. You can do sorting. So sorted, this sorted function returns sorted list and does not mutate L. If we compare it to the dot sort, this dot sort mutates L, and that reverse mutates L and gives L the reverse of the expressions in L, or rather the elements in L. I'm sorry, that should be elements. So in memory, list is, we can think of a list object like this one. It is an object in memory, so it is mutable. Therefore, an element in this list may be changed. A name or a variable name is bound or points to this object, and any other variable or any other name that binds to this list object actually can manipulate or can change the value of the elements in this list. So we have to remember, when we work with list, we have to remember the side effects of the changes that we apply on the list object. So let's say it's like this. Let's say we have Manny Pacquiao here. We can think of it as a person, and he has attributes such as he's a boxer, he is rich, he is strong. He is he has a name, Manny Pacquiao. So there is a name that binds to this person, Manny Pacquiao. We also call Manny Pacquiao, or this person, as Pac-Man. Some people know him as Manny. Some people know him as Senator Manny. All these names refer to the same thing or to the same person, Manny Pacquiao. So these are what we call aliases. If, let's say, we say that Pac-Man is a legend, it means that the legend is also applied to Senator Manny Pacquiao, and Manny. So a change that is applied to an alias or a name here is also applied to other aliases or other names. This is this is also how it works with list or with mutable objects in the memory. If we have a mutable object here, for example, a list, and let's say the name L1 binds to this list, and at some point we say that L2 um, binds to the same list object, it means they are referring to one object. Modifying L1 or modifying the elements of the list using the name L1 means modifying the elements of L2 also. That's why thinking about side effects is very important when we work with list objects. So that's aliases, and here are some examples, uh, code examples to look at it visually. So here in this example, H is an alias for warm because of this line 7. Hot is assigned warm. So warm, whatever the value of warm is assigned to hot. So here warm binds to this list object. Therefore, hot also binds to this same list object. Any changes with warm would mean changes with hot also. So these are what we call side effects. We can do a workaround with that. Let's say if we want them to have different objects to refer to different objects, we can clone the object or the list. So the way to clone a list is by using this colon inside a pair of square brackets. In this example, we have it on line 2. Chill gets cool square brackets dot dot or colon. So here we create a name chill, and that chill points or is bound to a new list object which has the same elements as the list object of cool. If we change cool, if we do mutation with cool, chill remains the same. If we do mutations with chill, cool remains the same because they are of different objects. So lists can, as I mentioned earlier, lists can hold an element that is of type list also. So we could have nested lists. So it's a list within a list within a list. Of course, since list is mutable, we have to keep in mind that it's still possible to have side effects if we have aliases or multiple names that refer to the same list object. So mutation and iteration, when we work with lists, we have to be careful that we have to be careful in mutating the list while it is iterating, because the as we go through the loop, the list also changes, and the counter that was originally set at the start of the loop remains the same and is not changed. So basically, we just have to remember about the side effects in working with lists. If you want to try or to imagine or to have a visual look of how your program works, especially with how your objects move and with how your objects are created and how they get value or how the values are changed, you may run your program and visualize it using the Python tutor. For now, that's all with for lists and tuples, and have a nice day.